Hello, this is Whitney Otan, Professor of Geology in the Department of the Earth Sciences at SUNY Brockport, and I'm here today to discuss today's topic, earthquakes, which is part of your Natural Disasters ESC 195 laboratory. As you know, earthquakes tend to be associated with displacements in the Earth's crust that are associated with plate motions. When tectonic plates either move together or compress together or move laterally against each other, stresses can build up in the Earth's crust. As plates tend to move against each other, they will begin to develop a stress in the rocks. The stress starts out as an elastic stress. The rocks will bend. And if enough stress is placed into the rocks, we can exceed the elastic limits of the rocks, and the rocks will actually rupture. They will break and then tend to cause an earthquake if they tend to break violently. This breakage sends a set of waves through the Earth's crust that produces what we know of as earthquakes. Once an earthquake is triggered by this breakage of rocks in the Earth's crust, there are several waves which pass through the Earth to produce the vibrations and the damages that are caused by earthquakes. The first and the fastest wave is what is called the P wave, or the primary wave. The primary wave moves through all materials, and it moves by a process we call compression and dilation. So the waveform itself, as it passes, tends to bunch together and spread out over time, analogous to the way pulling and pushing on a slinky would work. And this wave passes through the Earth's crust, through all materials, solid and liquid, and actually through the atmosphere, through gases, and produces the fastest moving waves. The second wave is referred to as the S wave, and the S wave travels along the Earth's surface, and it moves sort of laterally from side to side, analogous to the way the motion of a snake as it would pass across a land surface. The third type of wave that comes through an area when an earthquake occurs is called the surface wave. And the surface wave is a rolling wave which causes the land surface to sort of bob up and downward as the waveform passes through. Now, each of these waves tend to produce different sorts and different types of damages. Along with these waves, we can locate where an earthquake will originate, and there's two important points that are associated with an earthquake's location. First is the focus. The focus is the point that the rupture occurs in the subsurface within the crust. The second related location of interest is what is called the epicenter, and the epicenter occurs at the land surface directly above the earthquake's focus. So the epicenter provides us a geographic location from where the earthquake is emanating and spreading across the Earth's crust. These waves, again, travel at different speeds. The P wave is the fastest. It moves through all materials. The S wave comes through a location second, and it tends to move through solids only. It does not pass through liquids. And the third wave, the surface wave, passes across the land surface following the first two waves that would arrive at a site. The magnitude of an earthquake is associated with the size and the amplitude of these waves. The more stress that is locked up in the crust prior to rupture generates a larger energy release, therefore a larger waveform. And then next, the energy release will fade or dissipate as a function of distance from the epicenter. So typically, the closer one is to an epicenter, the greater the tendency for vibration, shaking, and potential hazard potential. So with that, hope you have a good day and enjoy today's exercise. With that, signing off, this is Whitney Otan.